Okay, so welcome, Jim Minie from Sertainty, security architect there. And today we're going to talk about self-protecting data and also dig a little bit into quantum computing or quantum encryption. So something a little bit on the future. Now, as I understand it, self-protecting data is also something when I looked it up, which was first in the research community, obviously. I saw some papers from 2011, 2012. Jim, could you talk a little bit about the concept of self-protecting data and why it's necessary and what the advantages are?
Absolutely, and thanks for having me here this morning, Patrick. The concept of self-protecting data, the technology itself is pretty simple. It's the idea of data that can actually protect itself. To this point, we've actually considered data fairly inert. It can't do anything for itself. All of the protection that we build to make sure our data doesn't end up on some website someplace has all been built externally to the data. Encryption does wrap the data or does scramble the data so others can't read it, but the keys and the management of those keys is all external. We do things like protect our networks with firewalls, protect our endpoints with AV and file management software. So what we're talking about with self-protecting data is the ability to have the data actually be conscious of where it is, what's happening to it, who's trying to access it, and be able to take action, whether that is to open or to even go so far as to delete itself if it feels it's under threat in a hostile scenario.
Can you give a technical overview of how is that done to the data?
Absolutely. So the things that we need to put into the data are basically everything that we've had externally to the data before. We need to infuse authentication, authorization for a user, the policies of what that user can get, behavioral reactions, the user IDs, the information of who can open that data. And in the end, we want to be able to log everything that's happening so we can take those the results, who tried to log in, who got in, where the data was opened, and take that back to a SIM or something for forensic investigation. So we're taking all of that data, all of that infrastructure, and building an engine, so to speak, inside the data itself. And in some instances, that engine still needs to be connected to an external policy server or another external server. In the most modern type, that data is actually on its own. You can actually send it like a spacecraft to the moon, and it's self-supporting. It knows what's going on without any external application, without any servers or anything that are reaching out. It's reaching out to know what's going on.
Okay, and what about how is the overhead of that self-protecting data as compared to if you just had the data on its own?
The data on its own is obviously X amount of bytes, and software encryption does cause the data to expand. Also, the fact that we're putting an engine or controller into that data as well, and it's not just a wrapper; it's actually infused into the data. However, with other techniques, we can actually cause that data to, techniques like deduplication, compression. We can actually keep those data files fairly small. They don't grow that large. On average, I would say it's potentially 100K per file, and that's a file from a meg to a terabyte of data.
And as the recipient of the data, do I see any difference? So if you want to send me, I don't know, PDF file, would I still receive that as a PDF file, or how would I open that?
Well, in the current manner, all files have to have an extension that is recognized by the application or the recipient. So in our case, and this is just one instance, it's a UXP file. That's an extension. The application, the plugin, whatever recognizes that as a file that is protected in a certain way, and that's where That's where the controls come in. When the file sees that it's a UXP, basically it's being plugged in like a vacuum cleaner, and now it knows that it's alive. It knows it has a motor, and it knows what to do. It's not saying that the UXP, the PDF reader, is actually going to try to open that. The file itself is opened by the self-protecting application, and then the PDF file is presented to the operating system as as PDF file, whereas Adobe will automatically open it then. So it's another step that the software has to take, but the user doesn't have to take anything, take any additional steps. They'll see that it's a UXP file.
But doesn't the user have to have an application which recognizes the UXP file?
Absolutely. That is the challenge to literally every new application that's out there. You mentioned PDF files. When PDF files were first invented, everybody had to get Adobe. Encryption, key management for being able to send and receive secure emails. That code needed to be built into the operating system. That would be the ultimate goal, would be to have this code as ubiquitous as possible. Across all operating systems, browsers, applications, and things like that. At this point, it is a file that can be downloaded from, say, the Apple iOS store, the Android store, download, into, Mac OS or Linux or Windows.
So, but is that UPX, is that a standard format then? I mean, I assume you're probably not the only provider of self-protecting data, but is that a standard, or is there a standard being developed?
It's a standard that's being developed. It's currently being worked on. We've been working on this for 4 or 5 years now. We actually just came out of stealth mode about a year ago, a little over a year ago.
Okay. Okay, good. Yeah, I think I get the idea, but if we look a little bit into the future, then on self-protecting data, if the infrastructure is built into the data, are there parts of the infrastructure where especially CISOs don't need to worry about anymore?
I'm sorry, can you explain that question?
Yeah, of course. What I mean is, if you mentioned nowadays we have firewalls, we have all sorts of different means to protect our data, password protection of data as well. If UPX becomes a standard and everyone has it, can I get rid of my firewall? Can I get rid of password protected data and stuff like that?
You'll need the firewall and the protection for all the other data that, just to keep the bad people out of your environment. There is always risk with data when it's unprotected. These days, we say we augment the existing security infrastructure in the environment. We don't eliminate it, but where we are seeing data going is out into the cloud, and I don't have control of it anymore. Or communication between two unknown parties. In order for encryption to work, say a VPN or SSL connection or an encrypted session, the two parties have to work out an agreement in the beginning. Do I have the two endpoints? Do I have a business need to create a permanent connection that's protected? In the smaller world, in the independent file world, I have to talk about, how am I going to protect that data and get it to you? In the case of a bank that wants to send money to one of your customers' payees, I have to set that up, and that's all. That's time consuming. If this became a standard, obviously I'd be able just to say, I'm going to send Patrick Bach $100. Or whatever, euros or whatever, and it would get to you, and you would be able just to click on it. Now there are technologies that are doing that, but they're all doing it with their own standards, as i.e. PayPal or Zelly or any of those different applications. So if I want to send you a secure file, I wouldn't need to set up a prior connection with you in any way.
Okay, so that means it's self-protecting data, and I heard that in the beginning, or at the previously before doing this interview. There's a lot of use cases. I mean, you just mentioned sending money, which would also be a use case. But I mean, some of the stuff, or a lot of the stuff, which self-protecting data can do, especially when we're just talking about PDF files or something, would also be possible with encryption, at least the protection part of it. Of course, not the data being able to recognize where it is, who is opening, if someone is opening, not those, but encryption itself is also a very strong protection, especially these days with the algorithms getting better and better. However, talking about the future again, Google built a quantum computer, or they said they built the first real quantum computer last year, and that would essentially render all current encryptions, not all of them, but most of the current encryptions useless. How does self-protecting data fit in there?
Okay, let me step back just a little bit to the original part of your question where you said, if I want to send data between two people, again, with encryption, I still need to set up that methodology of my encrypting the data and you're decrypting the data, whether it's the fact that we build a VPN or we have, we share our public keys, and I use that key, my private key, to make sure you get the data and only you can unprotect it, or anybody with my key can unprotect it, and then I use your public key to guarantee that I sent it to you, right?
Right.
That said, there still needs to be external communication prior to, I may send you a password on an encrypted file. So the idea of self-protecting data is the fact that I don't need to do that. My file contains all of its own protection and doesn't need that external connection. Getting into quantum computing, the idea that the quantum computers are in the future. They're still a ways away. We still can't afford. They're very computationally expensive, and they are, the two big functions that people are bragging about with them are the ability to break passwords and the ability to break encryption. The algorithms that are used for public key encryptions are the ones that are most susceptible to quantum computing. Symmetric keys, AES-256, the common keys, generally aren't. If I use a big enough key, and currently we're, a standard is AES-256, but as computing power goes up, that'll be easy to double that. By adding a single bit, I actually double the encryption of the previous, 256. I go 257, and now that encryption strength is twice as much, and it would take a lot longer for a quantum computer, when it's available, for us to be used to break that encryption. So in building a self-protecting data environment, the use of AES-256 keys internally, obviously, is the keys are built, the data is protected, and all of that happens inside the self-protecting data. So those keys are never exposed. When I send that file, the keys stay there with the file and are protected itself. So there is no external necessary communication prior to being able to unprotect that file. So that said, quantum computing is going to be a challenge. There's also quantum cryptography that will solve a lot of that problem as well. But right now, as expensive as quantum computing is, I still see it as being, down the road away, whereas self-protecting data is something we can implement, the next, immediately.
Okay. Just quickly, because I agree that quantum computing is still a little bit away, but nevertheless, don't you think it's time for companies to prepare for quantum computing now, before it's available, rather than, doing Absolutely. It when everything already happened?
And the idea of protection with quantum computing is all there. The idea of quantum, there's a word that I was looking for. Hold on just a second if you want. Blind quantum computing. I'm sorry that I had to go look at that. It's early in the morning here. But blind quantum computing, where I actually send my processing to somebody like a Google. where I can send my data, know it'll be processed, and still secure at the same time. So that is absolutely something large enterprises would definitely be looking at. But when you get into the smaller businesses, the smaller enterprises, the SMBs, the individuals, I see that quantum computing isn't going to be a valid solution unless the big guys, all build something that is aimed toward the small users, the individuals, the small businesses, and things like that.
Okay, and maybe going back to self-protecting data as such, there are other ways of encryption, like homomorphic encryption, where the user doesn't even decrypt the data as such. How does self-protecting data compare to that?
I'll compare and contrast both. Homomorphic encryption is a great philosophy. The ability to fully homomorphic encryption is the ability to have an encrypted file never be decrypted, and the user is simply working on that file as it's encrypted. Again, it's computationally expensive. It takes large machines. It takes a lot of processing power, and honestly, homomorphic encryption just isn't quite there yet. Again, it's going to be for the larger organizations. I just had a sit down with a company this past week who was looking for exactly that. They have a large finance company that wants to send them data. They want to process the data for business intelligence and then give the business intelligence back. But the large company doesn't want the processing company to see or know anything outside of the processes that are happening. So there's a demand for it, and I think people are really trying to build toward that. But I also see, quantum computing, shared quantum computing, quantum blind computing as being, another alternative to that. Now, besides being able to do that today, self-protecting data also has all of the parts that aren't included: the authentication, the authorization, the policies, the logging, the user IDs, and things like that. So it's still adding a lot to that, to the protection of the data.
But then taking your example of someone sending over large files or large volumes of data to another company just for processing because they don't have the power or whatever reason they have, then self-protecting data is also something which could be helpful in these use cases, right? I mean, you can actually see if the company actually just processes it or if they actually take a look at the data, right?
We do actually have companies using this for just about that exact scenario. We have companies sending data to other companies who are then breaking that data apart and processing that data in chunks. One of the things I didn't mention about self-protecting data is if I have a file that's say a 10 meg or 10, let's say 10 gig in size, I actually can break that data up into 1 gig pieces. And now I can create an individual symmetric key for each one of those 1 gig pieces. By policy, I should be able to allow you to see only 1 gig of that 10 gig, and unprotect that 1 gig. And that's exactly the use case that we're using. Is that our one of the users of self-protecting data is breaking that data open, only showing a small piece of that data at each station of a process. And then the other parts of the file remain protected. There is no, ability to even know that they exist, much less can you get into them. So what that does is it protects the data, allows policy access to just parts of the data or just certain files. If, for example, you've used self-protecting data on an entire file structure, an entire disk, if somebody were to actually break one of those keys, they only get a small part of that data. They don't get the whole file. It also prevents from the biggest problem with protected files, with encrypted files, is in order to work on them, you have to completely decrypt them. So I have to write the decrypted file to the drive, and now I have to work on that file, and then I have to bundle that back up and send it to somebody else. What did I do with the data? Did I delete it off of the drive, or is it probably still there? Yeah. So there's the human aspect of that as well.
So, I mean, we mentioned that self-protected data is a relatively new concept. So where do you see that go? Because it sounds to me that, there's quite a few use cases. I mean, if you look at the big issue of privacy, that's definitely something where self-protecting data can help or ensure privacy. Where do you see the self-protecting data heading in the next 5 to 10 years?
Everything from, every use case we have, whether it's industrial controls that need to be protected from hackers, financial, healthcare data, personal information, top secret data. Those are all natural use cases for self-protecting data. Going off into the future, literally you can protect anything and everything as it resides on a drive or is sent, across the internet or stored. We've actually had discussions with, and this is being spoken about at very high levels in the U.S. military. Remember those small files, the small file pieces that I talked about? I can actually break those apart and send just a chunk of a file to let's say, in a theater of war. I can send that over any transmission method, secure or not. So if something breaks down, if I have a radio vehicle that stops working and I can't get that transmission, can I transmit over a cell connection? Can I transmit that same file in any manner? I could actually just broadcast it on 5 or 6 different channels and have it received by the people who need to receive it. There are also just huge use cases in healthcare, where a user's data, if I enter my security information or my healthcare information in my I have apps on here for for heart rate, for blood pressure and things like that. I take that data and I protect it and send it to my processor, and they know that if it came from me, if I were to revoke my privileges, this works with the GDPR and everything. If I were to revoke my privileges, every file that I sent them is now, I can make sure that they can't read that as well.
Okay, so if I understand it correctly, especially the example you just used with the military, I mean, this is how the internet was created, right? I mean, the idea of the internet originally was to be able to send data even if one of the nodes in between breaks down. And a lot of people have been saying that when the internet was invented, or the ARPANET back then, that one of the challenge, or one of the problems which we face today, is that back then nobody thought of security. And it sounds to me like self-protecting data is doing exactly that. So it's going back to the original idea of the internet plus the security which wasn't there before. Is that something you could agree on?
It's going back to the origin of data itself. Data has been around since the Roman time. What is it? What is data? It's just information. But we've digitized that data and we've monetized it, and then now we send it all over the place. And how do I guarantee that that data remains secure? Because if somebody steals it, they can either steal the value completely for themselves, or they can reduce the value for me. So yeah, this is actually going back to looking at things from the very beginning. How are we doing things? Instead of trying to patch again and again and again with different methods of, I've been in sales for 25 years in security sales, and there's always that next new thing, right? There's that, what's best? A firewall invented back in the mid-90s is still a firewall. It still does the exact same function. It does 32 other functions, but it's still the exact same function. So we're looking at being able to protect data at the core level, so that all of these other security devices and software that we're using are more effective or less relied on to protect our data.
Okay, thanks, Jim Minie. I think that was a very good, some very good closing words. So thanks for having us. Thanks for your time, and yeah, it was an interesting talk about self-protecting data.
Thank you. I enjoyed it too.
Okay. Before I close the actual recording or the meeting, I can stop the recording now. But